Hi everyone. In today's video, we are going over the implementation of Vigenère Cipher in Python, and it complements the previous video that I uploaded about Vigenère Cipher, where I went over an example of Vigenère Cipher, a detailed example, and I hope this will make it more clear that how this can be coded in Python. So in the example that we we define our plain text to be I have a secret. So notice here I'm actually including uppercase letter, space, white space, things like that. This is just like just to see different scenarios where one could possibly face and how we can overcome this. So first, to get rid of the white space, we can just simply replace the white space with an empty string, and we see we got rid of white space. And to change, we still have one uppercase letter I. To do it systematically in Python, we can use the lower method, and we see that everything is now in lowercase. As a quick check, we now should have 12 characters in our string, which is expected. We define our key, which was the word police. Here I'm just gonna put them all lowercase, so no additional modification is necessary. And just to remind ourselves of ASCII characters, the ASCII number that corresponds to letter A is number 97. This is something that we will be using shortly, and the inverse operation is done by the ORD command. In the previous Python implementation that I went over for Caesar Cipher, I went back and forth between ORD and the chr command. This time I will just make use of that only one time, and we actually again, just to see different ways of approaching the same problem. This time we're gonna be using a dictionary. I'm gonna call it, create a new variable called EAM for English alphabet mapping. And I hope you're familiar with dictionaries. If not, please let me know in the comments and I may make a separate video about that. But basically, we want to have the letters, English letters on one side, and then the number that they associate to on the other side. So we do I minus 97 here because we're going to be using a as you can see, chr command. So this, for example, would corresponds to number 97, which is a letter A, and then we subtract on this side 97 from it because it has to correspond to number 0. For I in range, so here we want to go from start from 97 and cover the next 26 characters, because there are 26 characters in English alphabet. So this can be done easily like this, and we can see the output. So as you can see, we have English characters A, B, all the way to Z, and the corresponding number in front of them. So A corresponds to 0, Z corresponds to 25. These the items on the left are actually called the key, and the values on the right side are actually called just values. I'm not going to go over too much details of dictionary, but you can definitely look into that. We also need the reverse of this, and this is something that will be useful. There are different ways of changing the key and values in Python, but just to keep things simple for now, I will call this variable EAM reverse, or REV for reverse, and we're just simply going to copy paste this code and just simply replace the two. This should do it for sure. But again, there are other ways to achieve this as well. And here we can see now the key 0 corresponds to value A. And we can like use something like this code to get the value. So for English alphabet mapping, if we use this, we get 0. And for the reverse direction, we use let's say, a different number like 5. And we'll see it corresponds to letter F, as we can see here. So now we have this mapping. We can go ahead and transform our plain text and our key to a set of numbers as usual. We don't really need to divide our plain text or key into blocks. It is certainly possible, and I know when I went over Vigenère Cipher, I mentioned that we need to divide them into blocks, but for the purposes of coding, this is not necessary. You can get around it, and for the sake of at least this video, we assume that the length of the plain text is divisible by the length of the key, and if not, there are other methods such as padding, but we're not going to go over that, and we assume that the length of the plain text is divisible by the length of the key. Now we need to transform the characters in our plain text to numbers. So again, we use least comprehension here. So remember, our plain text is I have a secret. This will just I forgot to word in here. This will just give us the same string here, but one by one. And now we are interested in their the numbers that they correspond to, like this, and we can put it in a new variable called pt numbers, and we're gonna display it one more time as such. And we are going to do the same thing for the key. So we say key numbers is going to be EAM I for I in key, and we can display the values. I keep forgetting little things. There we go. So we see these numbers, they correspond to what we went over the example in the previous video. So you can go back and forth between them and check your understanding. Now, the next step, we have transformed the characters into numbers. Now, if you remember, we need to sum these values up. We need to sum them up. I'll try to keep things very Python friendly and keep it very simple, and try to use one-liners as much as I can. So if the next bit looks maybe a little bit overwhelming, don't worry too much. I'll try to explain. But again, there are ways to like break it down into smaller steps. If you're more comfortable with that, you can for sure do that. But I'll try to keep it very simple and use one-liners whenever we can. So as you can see, and as you might remember, we our plain text should be divided into two blocks. So for that reason, we need a second instance of this list to add to the PT numbers list. One way that that can be achieved is simply by multiplying by number 2, and this will add a second copy of the list to the same list. And the other concept that we need to be familiar with is the concept of zipping, which is done for adding tuples together. So there's this command in Python called zip, and if I do PT numbers and key numbers here, we'll get an iterable object. You can see the output isn't really meaningful to us. We can make it meaningful simply by using the list command, and this will show it to us in a nicer way. As you can see, we have numbers 8 as our first coordinate and number 15 from the key numbers as our second, and this applies to the rest of the list. As you can see, zip takes the minimum of the number of elements between the arguments that has been passed. So for example, PT numbers has 12 elements, key numbers has 6. Our output has 6 elements in total. We can make that work and make it the same like as PT numbers, which is our expectation, by multiplying by 2, which was mentioned here. So if we do that, we get the whole PT numbers component as expected. So now the other component that we need for the next part is knowing how to sum elements easily. In Python, there is actually a built-in command sum. Just keep in mind that sum takes a list or an iterable object as an input. So if I put 1 and 2, it's not gonna give me 3, which is what I want. But if I simply put it in a list, then it does sum the elements in the list for me. So we needed these 3 concepts, knowing how to add copies of the same list to itself, using tuple and the concept of zip in Python, and summing them. And now we can get our ciphertext in numbers, which is done by adding the plaintext elements and key values to each other. So we can call this next value variable CT numbers, which is, and again, we use this list comprehension. It's gonna be the sum of the 2 elements A and B, and these elements are found in PT numbers and key numbers. So we can write in here, we don't need to use list, we can just use zip, and that will do it for us, pt numbers, and the second components will be key numbers times 2, and we can display these values. So again, I might have made a mistake. I forgot to put them in a list. This should do it. So now we see we get the values of our ciphertext in numbers. So we can simply, this is where we take the mod of these values. So again, you can go back to the previous video and check it out, but we take the mod values to make these values between 0 to 25. For example, we have 29 and 33, so these need to be modified. Again, I'm just gonna update this list by taking I mod 26 for I in CT numbers, and I'm gonna display it. So as you can see, this number 29 here, by taking mod 26 has changed to 3, and that's because when we divide 29 by 26, the remainder is 3. One other thing that I like to point out is that here I used number 2 for multiplying. So basically, to know how many instances of the key numbers I need, I multiply it by 2. There's another systematic approach to this, and I prefer that. In general, my philosophy in coding is that um, try to keep it abstract as much as possible, and that will help to generalize your code for later use. So let's say if you needed like 3, 5, or n instances of your key, how would you go about it? There are a few ways. So and I give you 2 options. One would be simply we can multiply it by number 2, which is also the length of the plaintext divided by the length of the key. This will give us an error, and I tell you why in a second. It's because the way PT divided by length key works is that it gives us a float back, so 2.0, as you can see. So if I do key numbers times 2.0, this will give us the same error actually. In order to get around this, we can simply make it an integer, and this will work. So if I change this to int, this will work. And the other way is that we notice that 2 is the quotient of dividing 12 by 6. That will always give you an integer. So if we do len pt, and to find a quotient in Python, we use 2 forward slash, I believe, and then we can divide by the length of the key. And this is an integer, so we can simply multiply key numbers by this value here. And key numbers, that did not work as expected. Let us see why. If I look into the type, this is an integer, so I'm not really sure what is happening, to be honest. Well, Python is trying to play a game with me in here. I see what's happening. So what is happening is that in Python is multiplying these two first. The order of operation actually was wrong. So it's multiplying the list by this PT. So it's creating 12 instances of the key numbers, and then it's finding the quotient of this list when it's being divided by the key, which the length of the key, which actually doesn't make sense. That's why we get this error. So in order to fix it, we just need to put it around parentheses, which works fine. So we can actually define it in a variable called a number of blocks, and we can simply define it like this, and num-blocks should do it. So this gives us a more systematic way of approaching it, and we can simply write this code one more time, and instead of multiplying by 2, we can just use num-blocks, and this gives us the same thing. Yeah, and then we find these values mod 26. So we're pretty much done with the encryption component. The last part is to transform these numbers to their corresponding English alphabet values, which is actually done very easily. So we're just going to call this ciphertext variable. So here we are going to use the reverse of our EAM dictionary, which we already saved exactly for this moment, for I in CT numbers. And we can see that we get the ciphertext that was shown in the other video, and we can make it look nicer by using the .join command, and there we go. This is our ciphertext. So now we're done with the encryption component. We can move on to the decryption. I'm gonna go a little bit faster. Again, it's very similar to the encryption component with a minor difference where instead of summing these values here, we are going to subtract them. So suppose that we have this ciphertext and we have the key. We don't have any knowledge of our plaintext, and we don't, let's say we haven't done this a calculation or transformation before. We don't have this prior information. How can we go and decrypt this message using the key that we have? So first we need to transform these values back to numbers. So CT numbers is going to be, again, we are using the dictionary method here for I in CT. We're going to display the list and we get these values back. Now we can get the plaintext values in numbers really easily by subtracting a minus b. For again a and b, we are going to use the zip method one more time. CT numbers, and we have the key numbers. This time we can just use num-blocks again because it's the same number of blocks, that hasn't changed. And we can display the values that we get. Again, we see we got some negative values, which is fine. We can just find their values in mod 26. Again, done very easily in Python. So PT numbers, we're gonna update this. I mod 26 for I in the values of this list. Display list one more time, making sure everything works fine. So -5 is congruent to 21 in mod 26. -8, for example, is congruent to 18 in mod 26. So we got these values back. Now these are the values, these are the numbers that we need to map to their English alphabet to get back our plain text. Again, using the dictionary method that we've shown before, we can do that very easily. So we got EAM reverse this time. I for I in PT numbers, and we can display our plain text. And there we go. We see we get our plain text. I have a secret back one more time, and we can make it look nicer again by using the join command. There we go. I have a secret. We got our plain text back. This shows that everything works as expected. I'm going to share a GitHub repository that has the same code, but a cleaned version of this code. And I add a few more stuff, especially regarding how we can divide them into blocks if we want to. But as I showed to you and as I mentioned, there is no need to divide it into blocks. This code that I've shown you does the job. You can write functions to basically do this process for you in a faster time, but I just wanted to give you a basic tutorial and introduction without importing any modules. As you can see, there was no need for importing any package for Vigenère Cipher. Everything uses built-in functions in Python. With this, I hope you've enjoyed this video and maybe learned something new. As always, if you have any suggestions, feedback, please let me know. I love to hear from you. With this, we come to the end of this video. Thanks for watching and have a great day. Bye now.